like the push that gets electrons moving. Think of it as a kind of electrical pressure that propels electrons through a circuit. Just as water flows from a higher elevation to a lower one due to gravity, electrons move from a point of higher potential to a point of lower potential due to voltage. This movement of electrons is what we call electric current. The greater the voltage, the stronger the push, and the more electrons flow. This is why high-voltage power lines can transmit electricity over long distances, ensuring that even the most remote areas have access to power. Think of it as the energy boost per unit charge that helps electricity flow. Every electron carries a tiny amount of energy, and voltage is what gives these electrons the energy they need to move. The higher the voltage, the more energy each electron has. This is why devices that require a lot of power, like electric cars or industrial machines, often operate at higher voltages. They need that extra energy boost to function efficiently. On the other hand, smaller devices like your smartphone or laptop operate at lower voltages because they don't need as much energy to work. Imagine a 9V battery. It gives 9 joules of energy for every coulomb of charge. This means that for every unit of electric charge that passes through the battery, 9 units of energy are transferred. This energy is what powers your devices, from remote controls to smoke detectors. The battery acts as a reservoir of energy, ready to release it whenever needed. When you insert a battery into a device, you're essentially tapping into this reservoir, allowing the stored energy to flow and power the device. It's a simple yet ingenious way to store and use electrical energy. In a circuit, voltage is the driving force according to Ohm's law, V = IR. Ohm's law is a fundamental principle in electrical engineering that describes the relationship between voltage, current, and resistance. It states that the current flowing through a conductor is directly proportional to the voltage across it and inversely proportional to the resistance. This means that if you increase the voltage, the current will increase, provided the resistance remains constant. Conversely, if you increase the resistance, the current will decrease, assuming the voltage stays the same. This relationship helps engineers design and analyze electrical circuits, ensuring they function correctly and efficiently. More voltage means more current if the resistance stays the same. This is a crucial concept in understanding how electrical devices work. For instance, if you want to increase the brightness of a light bulb, you can either increase the voltage or decrease the resistance. However, increasing the voltage is often the more practical solution. This is why many household devices are designed to operate at specific voltages. By maintaining a consistent voltage, manufacturers can ensure that their devices perform reliably and safely. It's also why power supplies and adapters are rated for specific voltages, to match the requirements of the devices they power. From powering your phone